All right, lesson 2.3 is we're going to be talking about properties of exponents. And I'm calling this part 1 because I want to make sure that you guys really understand your property of exponents. Our learning objective for this lesson, students will use properties of exponents to simplify expressions. So today in part 1, we're going to be looking at multiplying these exponents, and we're going to look at the zero power, and we're also going to look at negative exponents. Okay, let's jump right on in. So first, before we get started, just to go ahead and kind of warm you guys up, we're going to start with a little warm-up. So the first question says, find the desired values for each function below. And then question number 2 says, write the equation for the following situation. All right, and then you have, it says Sam started a savings account with Wells Fargo with the amount of $25. During the initial meeting with the banker, Sam realized that his money would double each year. Okay, and so I want you to write me an equation to kind of simulate or to mimic that situation. Okay, now that you guys have time to think about it a little bit, let's dive into the first question. So f of x is equal to 2x minus 7. All right, and it wants us to find f of negative 3, and it wants us to find f of x is equal to 21, and it wants us to find f of 1/2. So the first one, it means that when f of x is, when x is 3, or when x is negative 3, what is my y? And we've learned that if I go to Desmos, let me pull that up real quick. We've learned that if we go to Desmos, we can very easily plug these equations in. So here we are, we have this equation, y equals, or f of x is equal to 2x minus 7. So I'm just going to plug that equation in. So instead of me saying f of x, I'm just going to use y because I realize now that they both mean the same thing. So I'm going to plug my equation in here. And of course, I don't get an exponential function, a curved line. I just get a straight line, which is okay because it's still a function. It doesn't change the fact that we're still looking for what the value would be on this line when x is negative 3. So in order to make this a little bit simpler, I'm going to convert this to a table. And so I want to look for these values. So I'm going to, yesterday we've learned, or we've been working with these tables in Desmos, so I know that I can plug any value in and get the value if I need to. So I know that when x is negative 3, I know that my value is negative 13. Okay. This is saying when x is 21. Well, I don't know when x is 21. So I need to look, or this is saying when y is 21. So I need to look for values for y. So I'm just going to play with some values. So I see that my value is 1 there. So I'm just going to play with 2. No. Okay. 3. No, but I can see we're going in a positive direction. Let's see. What about if it's 5? Okay, we're getting there. 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, so 14. Okay, so when my x was 14, it gave me 21, and so that's what my y value was. It was 21. So I can see that when y is 21 on this particular function, my x value would be 14. So this would be 14. And of course, 1/2, this is very easy. This is saying when x is 1/2, and yesterday we talked about 1/2 powers. So I can just come up here and plug in 1/2 here to figure out what that value would be. And so of course that is negative 6. All right, so the next question says, Sam started a savings account with Wells Fargo with the amount of $25. All right, so during the initial meeting with the banker, Sam realized that his money would double each year. So Sam started his account with $25, and the rate in which his money is growing is being doubled. So my equation will look like this. Okay, let's move on. All right, so today we're going to be talking about exponents. And you guys all know what exponents are. All right, so I don't have to go into detail, but what I do want you to understand is that when I write an exponent, I need to understand that an exponent is attached to a base number, or a base, okay? And this big number is what we call the base number. Now, this small number up top is what we refer to as the exponent. I would never come over here and write this exponent down beside the 2, because then at that point I would be saying 24 and not the exponent of 4. Those are totally different. Okay, so keep that in mind. You have a base number, and then you have an exponent that is a little bit smaller, and so you guys need to be able to recognize that. All right, and so basically what this exponent is telling us is that it's telling me to multiply this 2 4 times. The exponent tells me how many times to multiply the number it is attached to. So I got to take this 2, which is my base number, and I'm going to multiply that base 4 times. All right? And that's exactly what the exponent job is. That's all it does. It tells me how many times to multiply the base that it is attached to. Okay, now sometimes I know that we sometimes get a little bit confused about how to say these little statements, okay? So we have 2 and then an exponent of 4, or we have 2 and an exponent of 4. Understand that both of these mean the same thing. When you're typing something in your on the computer, you guys can use this caret key, and it's above the number 6. Okay, so if you hit shift and 6, it should give you this key, and then you can put 4, and that will let somebody know that you're saying that this 4 is an exponent, and you're not saying that this is the number 24. Because sometimes when you guys write the numbers close together and you don't obviously make this number smaller like this number, we sometimes get confused by what you're trying to say, and sometimes it confuses you as well. Okay, so that is 2 to the 4th power. And so we say this by saying we're taking 2 to the 4th power because the exponent is 4. All right, and if I were to see something like this, again, I have x. This is x to the 3rd power. Again, because your exponent is 3, so it is 3rd power. All right, if I see something like this, this is 2 to the x power. So I would say 2 to the x power. That's how I say this. It's not 2 to the squared power x. It's 2 to the x power. Whatever your exponent is, or whatever that little small number is, that is your power. We're going to call it power, okay? Just so that we're all speaking this common language. All right, so I have this. What is my exponent? 1/2. 1/2 can be an exponent, and it is perfectly okay. So this is x to the 1/2 power. The exponent here now is a fraction, in which we'll be working with that a whole lot. All right, and lastly, we have 3 to the -2 power. That negative can be a power, and we're going to be working with that a little bit more as well. All right, so now that we got that out the way, let's jump into our main goal for today. So today, what we're talking about, one of the things we're going to be talking about is multiplying with the same base, and we understand what base numbers are. So for an example, if I have 2 times 2 times 2, all right, I know that the base number is 2 because that's the big number. Now, the thing is next, what is my exponent here? If you said 1, you were absolutely right. all numbers have an exponent of 1. They're just not written there, but you need to know that 1 is there. Now, since they all have the same base, so I'm multiplying 2 times 2 times 2 times 2. All of these 2's are the same. They have the same base, so I can write this as 2 to the 4th power. Now, how did I get to the 4th power? That's because basically all these exponents, I've added them together. So let's dismiss this. I added 1 plus 1 plus 1 plus 1, and it gave me 4. I kept my base and I just added the exponents. And so this 2 times 2 times 2 times 2 is the same thing as saying 2 to the 4th power. Now let's look at another example. So I have y to the 5th power, and I'm multiplying that by y to the 3rd power. They have the same base. My base, they're both y's. And so as you can see, I have exponents that are there. And so what that means is I can add those exponents together to make this smaller because they have the same base number. They both have y's. So when I add those numbers together or add the exponents together, it becomes 8. So this simplifies to y to the 8th power. All right, let's look at another example. All right, so this time I have x times, and this means times 2. So don't get confused with that because I'm throwing some different symbols and things at you because you need to get used to seeing them that way. This means multiply. So I'm taking an x and I'm multiplying it to another x. Think of it as if it was written like this, okay? But this basically means the same thing as this. So have x to the 1st power. Remember, there is no exponent there, but it's still to the 1st power, times x to the 3rd power. They both have the same base. The base is x. So that means all you have to do to simplify this is to just add those exponents. So 1 plus 3 will give you 4. So this is x to the 4th power. All right. Now, what about this? So I have x to the x. I have x, and then I have y to the 3rd power. Are they the same base? No. And since they're not the same base, that means I can't combine them together. So how do I simplify that? Well, I just write them close together like this because this still means multiply. This means I'm taking this x to the 1st power and I'm multiplying it by the y to the 3rd power. And that's all I can do. I can't do anything else because they don't have the same base. All right, so here we go. The same base as we discussed, so therefore I can't simplify them anymore. This is as most as I could do for this one. Okay, so let's move on. Now we're going to talk about negative exponents. Well, how do we handle negative exponents? As you can see here, I have 2, and that's to the power of -3. Okay, so what my goal is to remove this negative exponent. Well, how do I remove it? Well, I just kind of do the opposite, okay? And I know that's funny because I said do the opposite, but let me show you what I'm talking about. So in order to remove that negative off of this 3, I basically have to flip it, okay? Because this is essentially saying, like 2 over 1, okay? Or 2 to the -3rd power over 1. Okay, this is a fraction, believe it or not. All numbers can be written as a fraction if I place a 1 under it. Well, because this number is negative, that means I now have to flip it. I have to remove this number to the bottom, which I did here. Okay, I moved the 2 to the 3rd power to the bottom, and when I moved it to the bottom, now the exponent becomes positive. Okay? And when you remove it to the bottom, you still have a 1 on top, okay? Because there's nothing left up there. So the only thing up there is a 1. All right. Let me kind of get rid of that. All right. So now when you flip it, you should get this. And as you see, you can simplify this a little bit more. Let me pull out my TI-84 calculator. Here we go. All right, so if I were to simplify this a little bit more, well, 1 is good. So I'm looking at the top of my fraction, and I got just 1 there. Well, I can't do anything there, but I have 2 to the 3rd power. So in my calculator, I just go 2 to the 3rd power, and that gives me 8. So instead of writing 2 to the 3rd power, I can just say 1 over 8 because they're all the same thing. Let's look at another example. So now we have x to the negative 2 power. Again, we have to flip it. We flip it, we get rid of the negative sign. So therefore, it becomes just 1 over x to the 2nd power. Well, I can't do anything else because x is not a number. So I just leave it written like this, and this is as simple as I can write it. All right, let's look at another one. All right, so we have 3 divided by 2 to the negative 4th power. All right, so of course we have to make this negative 4 because it's an exponent positive. Well, how do we do that? Oh, we're just going to move that exponent to the top. There's a 3 there. It doesn't matter. The 3 stays there. We move the 2 to the 4th power to the top. And so there's nothing on the bottom anymore except for 1. Okay, but I don't have to put that 1 there. All right, and it's a 1 there because anything can be divisible by 1 and it's not going to change the outcome. Okay, so that 1 is still there. And so this is what I have. And if I wanted to simplify this a little bit more, well, I can come over to my calculator and I can say 3, open parentheses, 2, raised to the 4th power. Where's 4? There we go. And close. Well, let's delete that because it'd be big around. There we go. Like that. I hit enter and I should get 48. So this simplifies just to 48. All right. So now we know that to remove negative exponents, or we remove negative exponents by moving the number it's connected to either the top of the fraction or the bottom of the fraction. It's just simple as that. You don't have anything else to do. Just move it. Move the exponent to make it positive. All right. Now, last but not least, we're going to look at what happens when we have exponents to the 0 power. So we have 3 to the 0 power. Well, that's just going to be 1. We have 25 to the 0 power. That's just going to be 1 also. We have 899 to the 0 power. Well, that's just going to be 1 as well. And then we have 1 million to the 0 power. And that's just going to be 1 as well. All right. So, and over here, we have x. And notice that they're in parentheses. So I'm taking this x plus this y plus this z. And I'm raising them all because they're grouped together. I'm raising them all to the 0 power. And guess what that's going to be? 1. All right. So anything to the 0 power is always equal to 1. Even x to the 0 power, that's equal to 1. All right, so now what I want you guys to do, I want you guys to try some of these examples on your own, okay, and play with the idea of working with these properties of exponents. And for this lesson, we looked at negative exponents, we looked at the 0 exponent, and we also looked at multiplying numbers when they have the same base, and what do we do with those exponents? All right, so I want you guys to take a look at this and try this, and then on tomorrow we'll come back together and take a look at it together.